So, the second exam. So let me do the answers. Okay, and I guess please again read and be familiar with all of the instructions before you come to class so that you're sure that you do not violate any of the policies and you know what to do. Problem number one. Solve the system of equations by graphing. Identify whether the lines are intersecting, parallel, or coincident. So let's graph the line. X equals 3. So 1, 2, 3. Y equals 2. So the point of intersection is the point 2, oops, is the point 3, 2. And of course, these are intersecting lines. Okay, let me do problem number 2. Solve the system. So let's, I guess, just multiply the first equation by -1, -2x plus y equal -1, and add it to the second equation so that my x's will cancel. And so the two x's cancel. 3y plus y is 4y. 8 minus 1 is 7. Divide both sides of my equation. One second. Okay, there. Divide both sides of my equation by 4. And so y is equal to 7 over 4. Let me plug that back into, I don't know, let's say the first equation. Or maybe I'll do it this way. So R1 is just going to be 2x minus 7 over 4 equals 1. Let me multiply both sides of my equation by 4. And so you get 8x minus 7 equals 4. Add 7 to both sides. So 8x equals 11. Divide by 8. And so you get that x is equal to 11 over 8. And so in this case, my solution is x is 11 over 8, y is 7 over 4. And you can solve this using any of the techniques, either elimination, substitution, or graphing. Yes, you can plug into any of the equations. So, except for obviously like you can't plug into like this equation, but any of the other equations that involve the unknown that you've solved for and one additional unknown that you have yet to determine. So if you plug into any equation that has one additional unknown, then you can solve for your unknown. Okay. Let me do problem number 3. Okay. So let me do problem number 3. Solve the system of equations by, substitution. So they want substitution. Identify whether the graph of the system consists of intersecting parallel or coincident lines. Okay, so I guess first let's so let's call this R1, R2. So let's use R2 to solve for Y. So let's divide each of these terms by 3. And so you get that Y is equal to 6 minus 2x. Let me call that equation S1. And so now let's substitute this solved Y into the other equation. Since we used R1, we'll substitute this into, since I've used R2, we'll substitute this into R1. And so if I plug S1 into R1, we get 2x plus y equals 6. Okay, and so let's remove the parentheses. If you do that, then you see that the 2x's cancel. So you just get 6 equal to 6. But that implies that, well, so certainly there are no x's or y's. So this will either be um, a dependent system or a inconsistent system. Since these two numbers are the same, this will be a dependent system. What's a fraction? Doesn't matter if it's a fraction or not. As long as if the two numbers are the same, then this will be a dependent system. This will have an infinite number of solutions. And so let's try to figure out what infinite number of solutions that these are. And so this will imply, so this is a dependent system. Which means that these are coincident lines, which is one of the things they ask you for. And so there are an infinite number of solutions. Let's find what the solutions are. Okay, and so let's find my one parameter family of solutions. So this will be a one parameter family of solutions. So let, I don't know, x equal t. Well, if I let x equal t and plug this into, let's say S1, then we get y is equal to 6 minus 2x, which is t. So therefore, my solution is x is t, y is 6 minus 2t, and this is for all real numbers t. And that is my solution. And so my solution looks like this set of ordered pairs, and they turn out that this is a pair of coincident lines. Let me do problem number 4. Solve the system of equations using elimination by addition. Identify whether the graph the system consists of intersecting parallel or coincident lines. Okay, so let's rewrite this first equation by subtracting 3y from both sides. So I'll rewrite it as 2x minus 3y equals 1, and 3x plus 2y equals 4. So that's my first and second equation. So let's get rid of the y's. So let me multiply the first equation by 2. So 4x minus 6y is 2. And the second equation by 3. 9x plus 6y equals 12. Let's add these. 4x plus 9x is 13x. The 6y's cancel. 2 plus 12 is 14. Divide both sides of my equation by 13. And so x is equal to 14 over 13. Let me, it really doesn't matter what equation I plug into. Maybe I'll plug into the second equation. So let's plug into R2. And so 3x plus 2y equals 4. And so 3 times 14 is 42 over 13 plus 2y equals 4. Let me multiply both sides of my equation by 13. And so 42 plus 26y equals 52. Subtract 42 from both sides. So 26y equals 10. Divide both sides of the equation by 26. So y is equal to 10 over 26. I can divide both 10 and 26 by 2. And so my solution is okay, well, I guess I didn't finish. On this equation, you are just leaving x alone. On the number 2 and 3 questions, you're leaving y alone. I'm not quite sure what you mean by that. You mean I'm eliminating x on exercise 2. Okay, so let's see. On exercise 2, I'm eliminating x. Correct. On exercise 2, I'm eliminating x. And our exercise is 3 and exercise 3, I'm substituting. Exercise 4, I'm eliminating y. Is that what you're asking? Okay. Okay, so the solution is 14 over 13. 5 over 13. And so these are intersecting lines, since I'm able to solve for this 1 point. And that is your answer. These are all part of one question. Okay, let me do problem number 5. So let's multiply this equation by 3 and add. And so 3x plus 2x is 5x. 7 plus 1 is 10. Oh, and the 3 y's cancel. Divide both sides of my equation by 5. So x is equal to 2. Now let's plug into, I don't know, let's say the second equation. So x plus y. So I don't know, this is R1 and R2, let's say. So let's plug into R2. Is equal to 1. Subtract 2 from both sides. And so, oops. And so, y is equal to negative 1. So my solution is 2, negative 1. Of course, this is a consistent system. These are intersecting lines. But they just asked to solve, so I don't need to do that. Let me do problem number 6. So graph this. Notice that x greater than or equal to 1. This will be a vertical line, vertical boundary line. This will be a solid boundary line, and this will be true to the right. Maybe I will, maybe I will shade it where it's false. So this is true to the right, so false to the left. Okay, let's do y greater than or equal to x. This again will be a solid line. This will be true above, false below. The slope of this line is 1, and the y-intercept is 0. It's a 45-degree angle. And lastly, yes, they'll put it over here. Let's subtract 3x from both sides. Divide by 4. And so you get y is less than negative 3/4 x plus 3. Oh, what do you get? Slope equals 1. This is in the form y equals mx plus b. What's the number in front of x? 1. What's the number added to x? 0. There's nothing added to x. So I put it into, it's already in the form of the standard form. It's already has the slope and the y-intercept. Okay? Okay, so now this is going to be a dashed boundary line. This is going to be true below, false above. And so in this case, the slope is -3/4, and the y-intercept is 3. So let's graph this. As best we can. Okay, so let's say 4, 2, 3. Okay, so we have here x equal 1, and it's solid. See if I can do this a little better. Having a little bit of trouble with the pen. It seems to actually be not locating where I'm putting my cursor down. Okay, close enough. It's as good as I can draw it without the pen is sort of skipping. Oh, that wasn't too bad. Okay, and it is false to the left. So let's get rid of all that. Actually, see, let's go over here, and I can get rid of all of this. Okay, so that's where it's false. So this is not, I'm getting rid of all this where it's not the solution. So it's not the solution over here. Definitely. Actually, there's no way I can. Let's see if I can. Okay. Okay. Don't go too far. Okay, let's go a little further down. See if I can make it look nice. Okay. Good enough. Okay. Next. X equals 1. Okay, so the y-intercept is 0. It's solid. And slope is 1. So over 1, up 1. So it's a 45-degree angle. And it's false below. So let's get rid of all this stuff below. Okay, good. Next, the y-intercept is 3. It's dashed. So, oops. Y-intercept is 3. It's dashed. And I go down 3 over 4. Okay, so I'm here. Okay, and get rid of everything above. So let's do that. Let's get rid of everything above. And that is your answer. And so now, so this is my solution. So my solution is that white, triangle that hasn't been shaded. And of course, the upper part of that triangle is dashed. Any questions about that? Okay, let me do problem number 7. The pharmacist has 40% and 70% iodine solutions. So 40%, 40% and 70% iodine solution. How many liters of each? X liters, Y liters. Of each iodine solution will be required to produce 6 liters of a 50% iodine solution. Okay, so we get point, so 40% of X plus 70% of Y is 50% of 6, and X plus Y equals 6. So let's multiply this first by 10. And let's multiply this by negative 4. So if I do that, I get, and maybe I'll call that R1 and R2, I guess. So I get R1. Oops, what happened there? Something happened there, not sure. Okay, so we get R1 is 4x plus 7y equals 30. R2, negative 4x minus 4y equals negative 24. Okay, so let's see. It probably means that you're having a hard time seeing. So let me just check. So that sounds like a desperate. Yes, it's not working. Okay. Yeah, that sounded like it. I'm going to have to. Yes, it's desperate. Can you see now? Okay. Can you see right now? Sometimes when I have that, when that glitch, it indicates that it's cut off the view. Yeah, now you can see. Okay, good. Okay, so so I had 40% of x plus 70% of y is equal to 50% of 6, and x plus y is 6. I multiply by 10 to get rid of the decimals. So I get 4x plus 7y. Get rid of the decimal. 5 times 6 is 30. Multiply by negative 4, so you get negative 4x minus 4y equals negative 24. Let's add. So the 4x's cancel. 7y minus 4y, 3y. 30 minus 24 is 6. Divide both sides of my equation by 3. Y is equal to 2. Let's plug into this equation here. So x, the second equation, plus y equals 6. Subtract 2. So x equals 4. And so that implies 4 liters of 40% iodine solution, 2 liters of the 70% iodine solution. And that is your answer. Let me do problem number 8. 2 cars start from 2 towns 400 miles apart. Where did you get the second equation? Ah, okay, so let's think of this. We have a little beak. Let's see if I can draw it. Okay. Those are supposed to be beakers, by the way. so, so we have. They look like shoes, actually, but I won't say anything. They're like 2 feet or something. So this is supposed to be X liters, and this is Y liters of a solution. And if you add those together, think of just pouring them, then we have another beaker, which even looks worse. So you have a larger beaker, I guess. And once you pour those in, you now have 6 liters. So X plus Y equals 6. Yeah, I know. Didn't really look like beakers, but you know what I'm talking about. So it's the amount of solution. No, X plus Y. Oh, how did I get the -4? Ah, because I wanted to cancel the x's. So once I get rid of the decimals, then to get rid of the x's, I multiply. If I have a 4x here, to get rid of the 4x, multiply this equation here by -4 to get rid of it. Is that clear? Okay. Yeah. Okay. Let me get rid of this horrible drawing. This is probably why you don't draw it. But you get the idea. I should bring little bitty beakers to school or something to show it visually because I can't draw, obviously. They do look like socks. I know they do. They they certainly didn't look like beakers. Okay, 2 cars. Okay, so we have here 2 cars, and they're originally 400 miles apart. Okay, and they're traveling towards each other. Let's say at X miles per hour and Y miles per hour. Okay. And they pass each other, so they're somehow, you know, meeting each other. Crash. Well, they don't crash into each other, but they pass each other after 4 hours. So after 4 hours, they somehow, meet after 4 hours, and they pass each other. Find the speed of each car if the difference between their speeds is 40 miles per hour. So, note distance equals rate times time. So let's do my first equation. And so the total, well, the distance that the first car has traveled is, well, it's gone for 4 hours and it's traveling X miles per hour. So the rate is X, the amount of time it's traveled is 4. Let's see how far the second car has traveled. Well, again, its rate is Y and it's traveled for 4 hours. Since they meet somewhere, they pass each other somewhere, then the total distance that they've traveled is this amount plus that amount, which is the total distance between these starting points, which is 400 miles. So the sum is 400. And it says that the difference of their speeds is 40 miles per hour. So let me just multiply the second equation by 4. And so if I just take R1 and take -4R2, No, actually, let's do positive 4. Try that again. 4. So I get a 4x minus 4y equals 160. Let's add these. So I get 8x, the 4y's cancel, equals 560. Divide both sides of my equation by 8. So x equals 70. Let's determine y. I guess let's use R2. So I get x minus y is 40. Subtract 70 from both sides. So negative y equals negative 30. Divide by negative 1. And so y equals 30. And so the speeds of the car are, well, one is 70 miles per hour, and the other is 30 miles per hour. Let me do problem number 9. Identify base and exponent and find the value. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. X to the 4. The base is 3x, and the exponent is 4. Okay, let me evaluate the next thing. And so, 4 times 8 is 32. I have the same base 10 and exponents. 14 plus 11 is 25. That's a relatively large number, so maybe, I don't know. Maybe I'll just leave it like that. You could write it as in scientific notation, but it doesn't tell you to, so maybe I'll just leave it like that. Problem number 11. Simplify. So this is equal to 8 times 8, 64. X squared is x squared. 3 to the 4th, 3, 9, 27, 81. X cubed to the 4th. Actually, let me put in an additional step. So this is 8 squared, x squared. Square everything inside, so it's 3 to the 4th, x cubed to the 4th. 8 squared is 64, x squared is x squared, 3 to the 4th is 81, 3x cubed to the 4th, well, 3 times 4 is 12. 64 times 81 is 5184. X squared times x to the 12th, well, that's 2 plus 12 is 14. And that is your answer. Okay. Let me do problem number 12. 3 to the fourth, 3 cubed, 2 cubed, 8. 3 to the fourth, 81. 8 times 81 is 648. 13, find the area of the following figure. Note that the area of a parallelogram is base times height. And so the area is base times height. And so 4 times 2 is 8. 3 times 1 is 3. X squared times x is x cubed. And that is your answer. Let me do problem number 14. Let's get rid of the parentheses. X cubed plus 2x minus 1 minus 4x to the 5 plus 2x squared minus 7x minus 1. So I'll change all the signs inside the parentheses. Combine like terms. And so I get negative 4x to the 5th plus x cubed plus 2x squared. I have a 2x minus 7x minus 5x minus 1 is a negative 2. And that is your answer. Let me do problem number 15, which is actually just about identical. If you have a negative in front of a parentheses, it always changes all the signs inside. It doesn't matter if the first or second. As long as you have a negative in front of a parentheses, it always changes all the signs. Okay, let me do problem number 15, which is, again, let's get rid of the parentheses. So 4x squared minus 3x minus 5. Since I have a negative outside the parentheses, I'll change all the signs inside the parentheses. So negative x to the 5 plus x to the 3 plus x plus 10. So I have negative x to the 5 plus x cubed plus x squared plus 4x squared. I have minus 3x plus x minus 2x, negative 5 plus 10 plus 5. And that is your answer. Let me do problem number 16. Multiply the following. And so let's multiply this. 9x squared, 4x to the 4, 6x squared, 4x. So by distributive property, I have 36x to the 6, positive times negative, negative, 54x to the 4, plus 36x cubed. And that's your answer. Let me do problem number 17. Let's multiply this out. So 4a minus 8b, 6a minus 7b. And so, actually, maybe I won't have enough space to do it like that. So let's multiply. So first, try again. first, outer, inner, last. So this is equal to 24 a squared minus 28 ab minus 48 ab plus 56 b squared. We can combine like terms. The 28ab and the 48ab. So I get 24 a squared minus 76ab plus 56b squared. Don't do it twice. Why do you keep doing this? Plus 56b squared. Okay. Let's see what the question is, and let's see if you can see anything. Error, error. Okay. Wait. Oh, okay. You're not only wait, but you probably can't see anything. So, wait. Privilege is removed. Okay, let's wait 1 second. Can you guys still see it? Or is this? No. Then why is it not letting me do this? Okay, wait 1 second. Let's see if I can. Can you see it now? No, this is not. No, no. This is on the PC. This is on a tablet. This is a Hewlett Packard. That's yeah. That's why it keeps glitching out. Okay, can you see it yet? Yes, you can see it now. Good, good, good. Okay. So, so first, outer, inner, last. So 4 times positive times positive, positive. 4 times 6, 24. A times a squared. Positive times negative, negative. 4 times 7, 28. A times b, ab. Negative times positive, negative. 8 times 6, 48. B times ab. Negative times negative, positive. 8 times 7, 56. B times b, b squared. Negative 28 minus 48, negative 56. Let me do problem 18. And so A, first, outer, inner, last. X times 2x is 2x squared. X times y, xy. Y times 2x, 2xy. Y squared. So this is 2x squared plus xy plus 2xy is 3xy plus y squared. And that is your answer. Let me do problem number 19. And so, this is one of the special product formulas. So 3 squared is 9, a squared. 3b times 3 times positive times negative is negative. 3 times 2 is 6 times 2 is 12. A times b is ab. Negative 2 squared is 4. B squared is b squared. And that is your answer. Let me do problem number 20. This is again, a special product formula. It's the product of the sum and difference of two terms. 2 times 2 is 4. 3 times 3 is 9. T times t is t squared. Positive times negative is negative. 2 times 2 is 4. 7 times 7 is 49. And that is your answer. Let me do problem number 21. And let me actually write down the formula. So 4a plus b quantity cubed is, well, first object cubed plus 3, the first part squared times second part, plus 3, first part times second part squared, plus second part cube. 4 cubed, 64, a cube. 4 square, 16 times 3, 48, a squared b. 3 times 4, 12, ab squared plus b cubed. And that is your answer. Again, you need to memorize all those special product formulas that you memorized last week. Actually, exactly 1 week from today, 1 week ago. And so, product of sum and difference is 2 terms. 4 times 4, 16, u times u squared. Positive times negative is negative. 5v times 5v is 25v squared. You are done. Determine the cube of the following binomial. So same formula as above. So 2u cubed minus 3, 2u squared, 3v, plus 3, 2u, 3v squared, minus 3v cubed. 2 cubed, 8, u cubed, 2 squared, 4, 3 times 3 is 9, 4 times 9, 36, u squared v, 3 squared, 9 times 3, 27, times 2, 54, u v squared, 3 cubed, 27, v to the third. And that, is your answer. Okay. Let me do problem 24. Let's raise each of these. So simplify and write the answer with positive exponents only. Let's raise each of these to the power -1. So x, 2 times -1 is -2. -2, well, actually, let me write this. X squared to -1. Y to -2, -1. Z to -2 to -1. And so I get here x to the -2. 2 times -1 is -2. -2 times -1 is +2. -2 times times -1 is a +2. Since I have a negative exponent, let me bring this from the numerator to the denominator. And so I get, I get y squared over x squared z squared. And that is your answer. We do problem 25. So I get 4 squared x to the 4 squared over 5 squared. 4 squared is 16. X to the 4 to the power 2. 4 times 2 is 8. 5 squared is 25. And that's your answer. Let me do problem 26. Simplify and write your answer with positive exponents only. And so let's raise each of these to the power of -3. So y to the negative 3 x squared to the negative 3, well, times x over y squared. So this is y to the negative 3 x over x to the negative 6 y squared. Since I have negative exponents, let's bring this one down and bring this one up. Okay, so I get x times x to the 6 over y cubed y squared, which is equal to x to the 7 over y to the 5th. Problem 27. Find a polynomial which when divided by 4x yields 3x cubed plus 4x squared minus 3 as the quotient. And so let's have 4x squared times 3x cubed plus 4x squared minus 3. Let's use the distributive property. Let's distribute the 4x squared inside the parentheses. So you get 12x to the 5th plus 16x to the 4th minus 12x to the 2nd. And that is your answer. 28. Divide x squared minus 2. So divide x to the 4th minus 2x cubed, no x squared, no x, plus 9. Okay, so I get here x 4x squared, that's 4x to the 4th, plus 0x cubed minus 8x squared. And let's subtract. I'll put it in red so you can tell it's something different. So the 4x, the 4's cancel. Negative 2x cubed minus 0x cubed is a negative 2x cubed. 0x squared minus a negative 8x squared is a positive 8x squared. Drop down the next term. So they have 3 terms. Negative 2x cubed divided by x squared is a negative 2x. And so you get a negative 2x cubed plus 0x squared plus 4x. Let me subtract. And so you get, well, the negative 2x cubes cancel. 8x squared minus 0x squared is 8x squared. 0x minus 4x is a negative 4x plus 9. 8x squared divided by x squared is 8. So let's subtract. And so 8x squared plus 0x minus 16. Let's subtract that. So the 8x squares cancel. Negative 4x minus 0x is a negative 4. Oops. Is a negative 4x. 9 minus a negative 16, say 9 plus 16, 25. Therefore, your answer is 4x squared minus 2x plus 8 plus a remainder of negative 4x plus 25 all over the divisor x squared minus 2. And that is your answer. Let me do problem number 29. Determine the quotient and remainder. And so you can do it by long division, or maybe I'll just do it by synthetic division. 1x squared minus 1y squared minus 1y minus 6. Drop down to 1. Times 3 is 3, minus 1 is 2. Times 3 is 6, minus 6 is 0. So your answer is y plus 2. Well, maybe I'll say the quotient, because it asks you for quotient, is y plus 2, and the remainder, which is this term here, is 0. Convert to scientific notation. So I have a negative. Let's write out the leftmost non-zero digit, 3. Place decimal, write out all the other digits till you get to the rightmost non-zero digit. So negative 3.754 times 10 to the, well, I have a leading 0. There's 1, 2, 3 zeros, so negative 3. Or it's the number of places that you've moved your decimal. In chemistry, the molar mass is equal to the atomic mass, 2.3244 times 10 to negative 26 kilograms, times Avogadro's constant, 6.023 times 10 to the 23 atoms per mole. Suppose the atomic mass of the element is 2.3244 times 10 to the negative 26 kilograms, and Avogadro's constant is 6.023 times 10 to the 23 per mole. Find the molar mass. And so let's multiply these together. 13.9983412 times, well, I have the same base 10, negative 26 plus 23, negative 3 kilograms per mole. And so move my decimal 3 over. And so you get 0.01399823412 kilograms per mole. And that's your answer. Find the greatest common factor. Well, for the constants, 4, 8, 90, it's just 2. The smallest power of x to the 6, x to the 7, x to the 8, x to the 6. For y squared, there's no y, so y to 0, and y, and so therefore it's just 2x to the 6. Factor out the negative, and so I can factor out a negative 8. What remains is p minus 5. And that is your answer. Factor by grouping. Group first two and last two terms. See if that works. It doesn't, because wait 1 second. There's nothing in common there. Oh no. Well, why don't I move things around? So let's move things around. So I guess I'll interchange the first guy and the last guy. Let's do that. So xy minus 4y squared minus 3x plus 12y. Group the first two terms, xy minus 4y squared. Last two terms, 3x, 12y. Be sure that since there's a negative on the outside, you change all the signs on the inside, which I did. Factor out what's in common. Y, what remains, x minus 4. 3, x minus 4y. And so what's in common? X minus 4y. What remains? Y minus 3. And that is your answer. Let me do problem number 35. So let's group the first two terms. Last two terms. Factor out what's in common. Y squared. What remains? Y minus 1. Factor out what's in common. 1. What remains? Y minus 1. And so what's in common is y minus 1. What remains is y squared plus 1. And we're factoring over the integers, or over the rationals, let's suppose. You could factor further if you're doing this, factoring over the complex numbers. Let's do problem number 36. Stuff you haven't done yet. And so let's factor this trinomial over the integers. And so I have a z squared minus 3x minus 4. So I'll put a z here. I have a minus sign, so let's drop down the minus. Minus times, so I drop down the minus sign. Minus times minus is plus. I want to find two whole numbers whose product is 4 and whose difference is 3. 4 and 1. And you put the larger of those factors first. Of the whole number factors first. Okay, let me rewrite this as 2y squared plus 8y minus 42. Let's factor out a 2. So you get y squared plus 4y minus 21. And now let's factor. So you have here a monic polynomial, so I can, a monic quadratic, so I can just bring down, factor this as y's at first. Bring down the plus sign. Plus times minus is minus. I want to find two whole numbers whose product is 21 and whose difference is 4, 7, and 3. And you put the larger factor first. And you are done. Let me do problem 38. Let me multiply this out. And so multiply 3y. Actually, let's not do that. Let's factor out what's in common first. And so if I factor what's in common first, I get a y plus 5. Factor that out. What remains is 3y plus 2, y squared minus 1. Let me simplify this. So let's multiply the 2 inside the parentheses. So I get a y plus 5 times 3y plus 2y squared minus 2. Let me rewrite this so it's in descending order. So I get y plus 5 times 2y squared plus 3y minus 2. So this is equal to y plus 5 times, I have a 2y squared, so I'll put a 2y and a y. I have a 2 here, and so I'll have a 1 and a 2. And let's check if the guess is correct. So I get 2y squared plus 4y minus y is plus 3y minus 2. And so I factored this correctly. Let me do problem 39. Um, let me actually factor out the negative first. So this is negative r squared minus 4r minus 32. It's a monic polynomial. So I have here r and r. Drop down the minus sign. Minus sign is minus is plus. I want two whole numbers whose product is 32 and whose difference is 4, 8, and 4. And that is your answer. Let me do problem number 40. X to the fourth minus 625. Well, luckily you have memorized your special product formula, so this is trivial. It's the difference of squares. And so this is equal to x squared minus, well, the square root of x to the fourth is x squared. The square root of 625 is 25 times, well, the same thing except one will be plus, the other will be minus. Again, this special product formula, difference of squares. And so x minus square root of x squared is x, square root of 5 is 5, times the same thing. This is the sum of squares. Turns out that sum of squares cannot be factored over the reals. And so you just leave it. And that is your answer. Let me do problem number 41. Factor. Well, luckily, will you stop doing this? Sorry. Did it glitch out on me again? Can you see? Is the answer. No, of course not. Can't see. Okay, let's see. Speedy. I know. Let's see. Okay. Um, okay. Can you see now? Hopefully. Tell me when you can see, I guess. Yes, you can see now. Good, good. Okay. So now I want to factor the following polynomial. Luckily, it's again one of your special product formulas, so you know how to factor it because it's a perfect square trinomial. The square root of 4x squared is 2x. I have a negative sign, so I'll put down the negative. The square root of 49 is 7. 2x times negative 7 is negative 14x, times 2 is negative 28x, which is the middle term. So yes, it is indeed a perfect square trinomial. So you're done. Let me do problem number 42. Again, factor the following polynomial completely over the integers. Luckily, you have memorized your special product formulas, so you know how to factor this because you've memorized it. The cube root of 8 is 2. The cube root of x to the 6 is m to the 6 is m cubed. The cube root of 125 is 5. The cube root of n to the 6 is n square. What did I write? Okay, let's try this again, even though the cube root of 8 is 2. The cube root of m to the 6 is m to the second. The cube root of positive 125 is 5. The cube root of n to the 6 is n squared. 2m squared is 4m to the fourth. If you square, the square of 2m squared is 4m to the fourth. Change the sign. 2m squared times 5n squared is 10m square n square. 5n squared quantity squared is 25n to the fourth. And you are done. Again, because you memorized your special product formulas last week. Factor the following polynomial completely over the integers. Again, you memorize the special product formula, so it's easy. The cube root of 343 is 7. The cube root of m to the 6 is m to the second. The cube root of 27 is 3. The cube root of n to the 6 is n to the second. 7, the square of 7m squared is 49m to the 4. Change sign plus 7m squared times 3n squared is 21m squared n squared. Negative 3n squared, quantity squared, is positive 9n to the fourth. And you are done. Again, another special product formula. Factor the following polynomial completely over the integers. This is sum of cubes, so this is the cube root of x cubed is x. The cube root of 27 is 3. X squared is x squared. Change sign. X times 3 is 3x. 3 squared is 9. And you're done. Same formula, well, as you did in problem 42, similar to 43. Let's do problem number 45. Solve the equation using the zero factor property. So just factor this. So I have 2x squared minus x minus 55. This factors into 2x, x. I have 55, so a 5 and an 11. And let's check if I factored it correctly. So 2x squared plus 10x minus 11x is minus x minus 55. Set these factor to 0. And solve for x. Add 11 to both sides of your equation. So 2x equals 11. Divide by 2. So x equals 11 over 2. Subtract 5, so x is equal to negative 5. So in this case, you have two solutions. X is equal to 11 over 2. X is equal to negative 5. Solve the following using zero factor property. Well, let's factor x squared minus 4. Well, again, it's a special product formula. It's different squares. Z minus 2, z plus 2. Z squared minus 64, again, special product formula, difference of squares. Z minus 8, z plus 8, equals 0. Set each factor equal to 0, solve for z. Z minus 2 equals 0. Z plus 2 equals 0. Z minus 8 equals 0. Z plus 8 equals 0. Add 2 to both sides of your equation in order to solve for z. And so z is equal to 2. Subtract 2, z equals negative 2. Add 8, z is equal to 8. Subtract 8, z equals negative 8. Solve using zero factor property. So first, let's distribute the 2x inside the parentheses. So you get 2x cubed equals 14x squared minus 24x. Subtract 14x squared, add 28x to both sides of your equation, 24x. to both sides of your equation. And so you get, so you get 2x squared minus 14x plus 20 squared plus 24x equals 0. Factor out the 2x. So you get 2x times, oh man, that's a cube. 2x times x squared minus 7x plus 12 equals 0. Let's factor this. And so I have here 2x. This is a monic polynomial inside the parentheses, so I'll put an x. Drop down the minus, times plus is minus. I want two whole numbers whose product is 12 and whose sum is 7, 4, and 3. Set each factor to 0. Solve for x. Well, I don't have any room. Divide by 2, so x is 0. Add 4 to both sides of the equation, so x equals 4. Add 3 to both sides of the equation, so x is equal to 3. Okay, let's do problem number 48. The product that measures the two complementary angles is 1496. Find the measure of the greater angle. So let x be the measure of the greater angle. Okay, and so the product. So notice that, well, the sum of two complementary angles is 90. So 90 minus x is the measure of the complementary angle. And so their product is 1496. So multiply the x inside the parentheses. So you get 90x minus x squared is 1496. Subtract 90x, add x squared. To both sides of your equation. So you get x squared minus 90x plus 1496 is 0. And so let's factor this. It's a monic polynomial, monic quadratic. So this will be x. Drop down the minus, times plus is minus. I want two whole numbers whose product is 1496 and whose sum is 90. Obviously, 1496 is divisible by 2. And let's see, 10 plus 10 is, so if you look at every other digit and added them, say the 1 and the 9, that gives you 10, the 4 and the 6 gives you 10. The difference is 0, so that's divisible by 11. So 1496 is divisible by 11, so it's divisible by 22, and you get 68. So it's 68 and 22. Set each factor to 0. And solve for x. Add 68 to both sides of your equation. Add 22 to both sides of your equation. And so the larger of the angles is 68 degrees. The smaller angle is going to be 22 degrees, obviously. So that's even though it's a correct answer, it's just not the largest one. So we'll get rid of that guy. So the larger angle is 68. Oops. I don't want that page. The age of father and son together is 48.
So the product of numbers representing their ages is 320. Find their ages. Okay, so let X be the age of the father. Oops. The sum of their ages is 48, so 48 minus X is the age of the son. The product is 320. Multiply X inside. So by distributive property, we get 40. We get 48X minus X squared is 320. Subtract 48X, add X squared to both sides of the equation. And so we get X squared minus 48X plus 320 equals 0. I can factor that as a monic polynomial. I drop down the minus, times plus is minus. I want two whole numbers whose product is 320 and whose sum is 48. Well, 40 and 8. Set each factor to 0 and solve for X. Add 40 to both sides of your equation. Add 8 to both sides of your equation. And so find their ages. Well, so so the father is 40 years old and the son is 8 years old. I'm assuming the father is older. So the age of the father is 40 and the age of the son is 8. Let me do problem number 50. The product that measures the two supplementary angles is 7931. So let X be the angle, one of the angles. Therefore, the supplementary angle is 180 minus X. And their product must be 7931. Let me multiply X inside the parentheses. And so you get 180 X minus X squared is 7931. That's nice also. And so let's subtract 180X, add X squared to both sides of my equation. So you get X squared minus 180X plus 7931 is 0. This is a monic polynomial, so I can factor. Drop down the minus times minus times plus is minus. So these are both minus. I want two whole numbers whose product is 7931 and whose sum is 180. So first off, notice that, well, again, 7 plus 3 is 10. 9 plus 1 is 10. So 10 minus 10 is 0. So therefore, it is divisible by 11. And not only that, if you take the 793, subtract, so get rid of the 1 and subtract twice that, 791, that's divisible by 7. Well, if you don't see that, subtract the 2 from the 79, so you get 77. That's certainly divisible by 7. So the 7931 is divisible by 77, and so that's 103, because that's 77, and that is 23231, and that's 7931. Okay, and so set each factor to 0. and solve for x. Add 103 to both sides of your equation. And so x is equal to 103. X is equal to 77. So find the measure of the two angles. Well, one angle is 77 degrees and the other angle is 103 degrees. So, and those obviously are supplementary angles. So, um, that's it, I guess. Any questions? If there are no questions about that, then we're done. So, no group work this weekend. Just look over this exam. Look over section that was 6.2. So look over section 6.2 for Monday, and then we'll answer some questions on 6.2 on Monday, and I'll give you a group work during class on 6.2. Okay, so I'll see you on Monday. And let me get rid of everyone. Yep, so no group work this weekend. Correct. They'll be done in class. Yes.